Hello, friends. Today we're diving into a story that reshaped the skies of World War II. A story of misjudged intelligence, brilliant engineering, and a bomber that would redefine strategic warfare. This is the story of the Avro Lancaster. In late January 1942, German reconnaissance aircraft returned from missions over Britain, carrying photographs that would alter history. On the tarmac of RAF stations in Lincolnshire and Yorkshire, German intelligence analysts spotted something new: another four-engine bomber. To the analysts at Luftwaffe headquarters in Berlin, it seemed unremarkable. Britain had been designing heavy bombers since 1939, and by all accounts, most were failures. The short Sterling couldn't climb above 15,000 feet without struggling. The Halifax frequently shed tail units mid-flight. The Manchester, a twin-engine catastrophe, had already been withdrawn from active service. So when reports of this new aircraft, then known as Type 464, landed on German desks, the verdict was predictable. Four engines, a conventional mid-wing design, twin-tail fins, nothing revolutionary. Just another attempt by Britain to create a strategic bomber in an industry that seemed incapable of matching German or American engineering. The wingspan measured 102 feet, comparable to other lumbering RAF four-engine designs. Chief Luftwaffe Intelligence Officer Obst Josef Schmidt filed the reports with dozens of other British aircraft considered negligible threats. On paper, this assessment was understandable. Britain's heavy bomber program had been chaotic for years, plagued by contradictory Air Ministry specifications, demanding planes that could somehow serve as both strategic bombers and tactical support. Aircraft manufacturers responded with compromised designs that excelled at nothing. The Sterling entered service in August 1940, already obsolete. Crews called it a death trap. Interrogations of captured RAF airmen revealed chronic mechanical failures, inadequate defensive armament, and bomb loads that barely justified the fuel used to reach targets. Compared to Germany's Heinkel He 177 or even America's B-17 Flying Fortress, Britain's heavy bombers seemed doomed before the first operational mission. But what German analysts missed entirely, what no reconnaissance photograph could reveal, was revolutionary: the Lancaster's enormous, unobstructed bomb bay. While analysts measured wingspans and engine types, they didn't notice the one specification that would redefine strategic bombing: 33 feet of uninterrupted space through the aircraft's center, ready to carry payloads thought impossible by engineers across Europe. The story begins with one of Britain's greatest aviation failures. In July 1936, the Air Ministry issued specification P-1336, a twin-engine medium bomber capable of carrying 8,000 pounds of bombs over 2,000 miles. A logical concept. Two engines meant lower costs, less fuel, simpler maintenance. Avro's chief designer, Roy Chadwick, responded with the Type 679, later known as the Manchester. The Manchester first flew in July 1939 and failed spectacularly. Its Rolls-Royce Vulture engines, essentially two V12s on a single crankcase, were disasters. Connecting rods snapped, cylinders cracked, and coolant systems leaked. Crews lived in constant terror. Engine failures were frequent, fires inevitable. Within months, the Manchester earned a reputation for killing its own crews. On February 24, 1941, Flight Lieutenant Sherwood's Manchester lost an engine 20 minutes after takeoff. He barely coaxed it across the North Sea. 3 crew members bailed, certain death awaited. By June 1941, the Manchester was withdrawn. Yet Chadwick saw potential. The fuselage was sound, the wing structure solid, and the large bomb bay, designed for 8,000 pounds, was precisely what Bomber Command needed. The solution was brilliant in its simplicity. Scrap the Vultures, extend the wingspan from 80 to 102 feet, and install 4 Rolls-Royce Merlin engines, the same engines powering Spitfires and Hurricanes with legendary reliability. Individually, each Merlin produced 1,080 horsepower, less than a Vulture. But 4 together gave over 5,000 horsepower without catastrophic failures. By January the 9th, 1941, the first Lancaster prototype flew. Test pilot Sam Brown reported perfect handling, responsive controls, and a bomb bay that remained intact. Chadwick had taken Britain's worst operational bomber and transformed it into a machine with unprecedented capability. By Christmas 1941, Lancasters were arriving at operational squadrons. German intelligence noticed, but assumed it was just another mediocre replacement. What they couldn't grasp, the Lancaster could carry massive payloads over operationally useful distances with remarkable efficiency. 4 Merlins delivering nearly 6,000 horsepower combined provided enough thrust to cruise fully loaded at 20,000 feet, high enough to avoid the heaviest flak concentrations at speeds of 287 mph, or its aerodynamics were optimized for lift and minimal drag. Flush riveting, carefully faired engines, streamlined turrets, every detail mattered. By early 1942, the Lancaster routinely carried 14,000 pounds of bombs on raids deep into Germany. German intelligence dismissed these claims as exaggeration. How could a 68,000-pound aircraft carry more than 20% of its weight in bombs? For comparison, Germany's Heinkel He-177 maxed at 4,400 pounds. American B-17s rarely exceeded 6,000 pounds in real missions. And yet, Lancaster crews flew mission after mission, delivering tonnage that systematically devastated German infrastructure. The numbers are staggering. 156,192 sorties between March 1942 and April 1945. Lancasters dropped 612 tons of bombs, 64% of all RAF Bomber Command ordnance. Halifax's dropped 227,610 tons. Sterling's just 15,300. Reliability made these statistics possible. Lancaster abort rates were half that of other heavy bombers. The human cost was immense, 3,049 Lancasters lost in operations, 2,340 more damaged beyond repair, and 55,573 aircrew killed, a 44% fatality rate. But Lancaster crews had slightly better survival odds, thanks to robust design and efficient defensive systems. Flight Lieutenant William Reed's mission on November 3, 1943, exemplifies this courage. His bomber was attacked by multiple fighters over the Dutch coast, sustaining heavy damage and casualties. Yet he delivered his bombs and returned safely, earning the Victoria Cross. By late 1943, Lancaster payload capabilities inspired visionary engineers. Wallis, creator of the famous bouncing bomb, designed earthquake bombs like the Tallboy and Grand Slam, intended to destroy heavily fortified structures. The Lancaster's bomb bay, structural resilience, and Merlin power made it possible. On June 8, 1944, 617 Squadron dropped the first Tallboy on a French railway tunnel, collapsing it completely. Subsequent attacks on battleships in Norway demonstrated unmatched precision. Heavily armoured vessels sunk by bombs dropped from 3 miles high. Against all expectations, the Grand Slam, 22,000 pounds, 35 feet long, penetrated up to 100 feet underground before detonation. Stripped of non-essential equipment, Lancasters carried these weapons with daring efficiency. The Bierfeld Viaduct raid on March 14, 1945, destroyed previously indestructible infrastructure, proof of the Lancaster's absolute limits. Operationally, Lancasters dominated the night skies. By 1945, Bomber Command routinely dispatched 700 Lancasters per night, each carrying 14,000 pounds of bombs, 9.8 million pounds of ordnance in one raid. German defences, still reliant on night fighters like the Messerschmitt Bf-110 and Junkers Ju-88, could not keep pace. Night fighter losses rose unsustainably. German tactical doctrine had to adapt, but by then, Germany's industrial base was shattered. The Lancaster's influence extended beyond WWII. The Americans developed the B-29, emphasizing payload over defensive armor, and the Soviets designed the Tu-4 with massive, unobstructed bomb bays, reflecting Lancaster principles. British post-war designs, the Avro Lincoln and the V-Bomber Force, also prioritized bomb bay volume and payload. Strategic doctrine shifted. Tonnage delivered became more important than survivability of individual aircraft. From the first operational raid in March 1942 to the final missions of April 1945, the Lancaster redefined heavy bombing. It wasn't just a bomber. It was a revolution in aircraft design, engineering, and strategic doctrine. Payload capacity, reliability, and operational efficiency. These were the Lancaster's legacy. So the next time you think about strategic bombing, remember, the Lancaster wasn't just a plane. It was a machine that turned the tide in the skies, reshaped military thinking, and set the template for decades of bomber design. And that's the story of the Avro Lancaster, the aircraft that defied expectations, outperformed intelligence estimates, and changed the course of strategic bombing forever.